discussion for today is general inspection. So I will share another photos that I have taken during my inspection visit on a particular job. This is just like a renovation job for an existing mechanical systems, fire protection systems, and energy code inspection. So let me show you some photos that have been taken, that I have taken on the job. So for mechanical system, this is the ductwork that the reference drawing plan. Uh, see all this ductwork size. You need to verify this on the job if the drawing plan has been followed strictly. And the equipments right here, these are all the shaded part is the existing system. So you need to identify only the new installation. This is exhaust fan 3, exhaust fan 2 and 1. 2 exhaust fan 1 and 2 is connected to one riser. This is the round thing is going to the roof, and this is the branch duct. Exhaust fan 3 is probably this is a janitor closet. Yeah, it's a janitor closet. It was. And these are the toilets, men and women toilet. These are the RTU, the rooftop unit. So this is another riser. This is an intake for uh the inside air, so it will recirculate the air inside the building. So this is a volume or motorized damper here, or this is a sensor for the duct. And you got the AC one. This is a air curtain by the door entrance. So you need to identify all those equipments are installed as per drawing plan. Any changes should be noted, marked in the inspection, should be approved by the engineer of record or the designer. And this is the uh, what you call the drawing equipment schedule. So this is the air curtain. You got the manufacturer, the designation here, service area, manufacturer, and the model number. So this should match what the contractor will install on the job. So ARD 12. That's the model number. And this is the rooftop unit model number. So this is the manufacturer and the model. That's the specs. This is the rooftop specification of the drawing. So need to match what will be installed. So for some condition that if they have installed a different one, you need to have approved submittals, approved documentation that will support the actual unit that will be installed, that you're gonna identify during inspection. So this is the exhaust fans, the manufacturer's Green Hack, I mean, sorry. And this is the model number, SP80BG. So this is an easy similar model number to be identified. These are the air, grill, register, and diffuser. So this also a particular model, manufacturer. So anyway, if you cannot identify all those model numbers in the grill, so you could just ask for approved documentation or the paper that has the description of the device or the equipment. So this is the air curtain unit on the job by the front door. As per drawing, it was installed as per the plan, and this is the model number. That's the manufacturer. This matches the drawing specification, ARD12, and the manufacturer. So this is conformance. And the ductwork, you see, as you can see, the ductwork is layout as per drawing plan. The size, You could say uh, estimate, or you could, if you could measure, that's much more preferably to confirm, to verify if the ductwork is matching with the drawing plan, the size, and you should also look for the supports, the ceiling hangers. Support should be space acceptable as per code and as per drawing details. So more likely, probably every turn should be supported, and hanger support should be at least 6 to 10 feet, depending on the condition of the job. And you see light fixtures are installed also. So under energy code drawing, I have a reference that I will show you in the slides and the photos that I've taken. So referencing all the installation and the specs, the wattage rating should be identified also. So these light fixtures will fall on interior power inspection, interior lighting, interior lighting power under energy TR8 energy code inspection. So this is the exhaust fan that's specified. So this is either exhaust fan 1, 2, or 3. So you need to check on the flexible duct connection if it's connected well. Those uh, uh, connected tight to the main exhaust duct going out on the building. And so this the model number and specs. So you can see here it's a very difficult task to do, to take a photo when it's only your phone that could get into the grill. But take your best effort until you have a visible manufacturer and model. So I took several photos until I get this clear one. So SP80 and the green hat model manufacturer matches the drawing. So this is conformance. And this is the main exhaust duct. So this ductwork doesn't need to be insulated because you're throwing out air from inside to outside the building. So it's not a conditioned air duct. The only thing here that you need to comply with the drawing is the layout, the termination, and especially the support. So as you can see here, this is only sitting on the existing wall frame stud. So don't think this is acceptable. So you could tell the contractor to have a hanger support from the top and hanger it properly, because in the long run, this system will be right here for the next 10, 20 years. So it's not acceptable to have an installation without a proper support. And right here, I'll show you. I took a photo because of the new piping, domestic piping insulation. So I'm showing here. And this is a good opportunity to take a photo while the ceiling are not covered. The drop ceiling tile is not installed. So you can see here all the piping are the copper piping for the domestic water is insulated. So that's under energy inspection too for the insulation. And same thing right here. And so this is the ductwork. That's the main ductwork going to the roof, going to the rooftop unit. So the rooftop unit, this is a centralized air conditioned area. So the rooftop unit will produce cold air during summer and hot air during winter. So it's a conditioned air. Uh, so it's a climate control system. So it's the rooftop unit is what you call one of the definition is the economizers. And you can see the ductwork here. It's insulated but the riser was not. So in this case, it's either the ductwork is existing and it has an existing uh, liner of insulation inside. So that's what you call a liner when it's insulated inside. So the new ductwork, the horizontal ductwork hanging uh, on the top of the drop ceiling is insulated. So this insulation is required for energy code requirement 2. So you need to identify the R value of the wrap the wrapping insulation of the ductwork. So this is R4.2, you can see here. And I'm sure that R6 is required on the current code requirement. There is an exemption if the engineer will see to that exemption and say this is okay for the job, because I think this is a conditioned air and there is 10 degree Fahrenheit, I believe, difference for the ductwork to be insulated and not insulated. So this is a conditioned area. So if there is a far much different in temperature between the ductwork and the atmosphere inside the building, it should be insulated properly, like the on R value of 6. Oh, so this in this case, you only have R4.2 value. So it's either the engineer will approve or the contractor needs to correct the insulation of the duct. So take note in the report for that. This is a new boiler, water heater, I mean. It's for the domestic water. So I believe that's under HVAC service water heating inspection for energy code. And this is a flexible ductwork connection from the exhaust fan on the toilet or janitor closet. And right here, this is the termination of your ductwork exhaust duct. So in this case, they instead of going up to the roof, they make the ductwork, the exhaust duct, penetrate the wall, the vertical wall, going to the back of the building. So that's the change that so far I have identified on the actual installation compared to the drawing reference. So this is another ductwork. Inspect the hangers should be provided. Connection should be sealed up, and ductwork should be uh insulated, wrap, complete with wrap insulation. That's the riser and our values. And I took a photo of this again because I noticed something. So the fault here is the sprinkler. As you can see, this is not acceptable. Uh, I'm not sure. I can't remember if this is a existing sprinkler or a new installation, a sprinkler under fire protection system. But either way, if it's existing or new, this is not acceptable because the sprinkler head is on top of the light fixtures. So in case there's a fire condition on the area beneath the light or beneath the ceiling, this will be spraying on top and this will not kill the fire on the area. So they need to have the correction here. And this will make also a penalty for the building department if they saw this. So the sprinkler needs to be correction. It needs to be corrected. You can see. And this is the exhaust of the ductwork. So it's protected. It was the backdraft damper was provided. So this will, every time the exhaust fan will throw out air, this will open out. And if it's windy outside or this will be closed down and prevent air from going inside if you have a air conditioned area. So this will prevent air from going in, cold air during winter and hot air during summer, so that your conditioned air is not compromised, or you will save energy on the inside. You're not gonna make the air conditioned unit run in either condition during winter or summer. So that's a prevention of unconditioned air from the outside. This is the installation of your refrigerant piping, computer area. So this is the split type unit. How they installed it should be based on the manufacturer's recommendation installation. And you need to identify it. This is the manufacturer and model number. So it needs to comply with the drawing specs and the design. So either way, as I said, if it doesn't match with the drawing, they're gonna have, you need to ask for approval from the engineer or approve submittals that this is acceptable for the job. And this for under fire protection, this is the fire stopping material. So you can see this is the material they use only for true penetration, as it was specified here. So this is material is not applicable on wall-to-wall joints, the corner joints. So this only applicable for true penetration like ductwork or piping penetration. So you can see it right here, typical application. Metal pipe, plastic, gray, busways, insulated pipe, HVAC ducts. Oh, it's applicable only for penetrations. And some installations. So the rooftop unit wasn't installed yet. So this is the mounting base for the rooftop unit. And this is the supports for your uh, refrigerant piping vertically. So this is the ladder going to the roof, and they have supported the piping through the wall. And piping of the refrigerant should also be insulated. I need to identify how much the thickness, and the R value is 5.1. I believe the last time I see the requirement for refrigerant piping is R3, so this is acceptable. R 5.1. It's more than 3, the R3 value, so it's R 5.1. And that is the penetration. This is the material, Firestopping material, the red stuff. And this is the rooftop unit, model and manufacturer. And this is the water heater. So you need to identify model and manufacturer too, and compare it with the design, the specs, the drawing equipment schedule. And we go in for the lighting controls. This is the manual on off switch. This is the motion sensor switch with manual control combination. And the light fixtures layout installation. And I identified the light, also the specs of the light through here. So this is the 14 watts, constant power. So there is a light power density that it needs to comply. So you need to count all the light fixtures, sum it total every wattage, and divide it with the total workplace area where the lights are installed. So there is a light power density limitation. If your quotient, your result, it goes more than that allowable light power density. So you could say if it's energy wise, or you could ask the engineer if this is acceptable before you sign up the job. This is another penetration in the wall for the exhaust ductwork, complete with fire stopping. And the refrigerant piping, this is the yellow stuff. I think this is a power blocking. This is not acceptable as power stopping material. This is power blocking, so you could use this power blocking to minimize the gap between the penetration of the wall and the piping. But you need also to put the red stuff, the approved power stopping material. And there's another light fixture that I identified. So this is a light controls. So this is a watt stopper. This is a programmable device that will uh, make the owner of the building to turn off the lights after work hours and turn it on before work hours. So it depends on the schedule of for the working days and weekend work. So they could program this before office hours. The lights are on 30 minutes an hour before, and the lights will be off after all the workers are out the office, like an hour or more or less. So it depends. So this is the control panel for the lights, light fixtures and exhaust fan. And here, obviously, this is not the complete installation of the sprinkler. So this sprinkler head needs to be flush on the ceiling. And this is a ceiling motion sensor. We cover it with the black tape uh, just to test it. Uh, because it's a motion sensor, we test the probe so that it will not sense any motion within the area. So on that time, I think the setting is like after 15 or 20 minutes without any movement or motion, the all the lights should be off, uh, any in any particular area. And by the time we remove the cover tape, it will turn on the lights. So that's the purpose of the test. This is the wall control motion sensor. We also tested it by covering with black tape. And that's yeah. So this is the drawing plan for the light fixtures. So it has some emergency lighting like this. That's the designation symbol for the drawing. So you need to comply with the drawing plan also. So emergency lighting and some sizes of the light fixtures, the wiring, the specs, light fixture schedule. So this is the schedule, that's the size. So comply with the drawing. You need to comply with the drawing, and if any changes, it should be noted and addressed to the engineer. Mm, lighting controls, schedules, and that's the support for the pipe. And this is the corrections, the highlights that I made on the drawing reference. So instead of the exhaust duct work going up to the roof, so this is the actual installation that they did. So instead of going to the roof, they installed the ductwork horizontally and penetrating the wall at the back of the building. As as I could, as I have previously showed you, there's a backdrop damper on the wall to prevent air going in, going back to the area inside the building. So this is another correction for the engineer to make for the drawing. So because the plan is a 6-inch or 8-inch through roof going to the roof, terminate and gooseneck. So that's the original plan. So you make the engineer approve this installation. So instead going to the roof, it was going to the back of the building at the wall penetration. And the engineer needs to amend or update the drawing itself. So because they're gonna need to have to file this to uh the building department. So that's it for today. See you in the next one.